Okay, this is a disc of ceramic superconducting material, high temperature superconducting material. This kind of material was discovered in the mid-1980s, and it becomes superconducting, which means that it can conduct electricity without any resistance at above the boiling temperature of liquid nitrogen, which is minus 196 degrees Celsius. Before that, you had to cool materials down close to the boiling temperature of liquid helium, which is minus 269 degrees Celsius. And in addition to conducting electricity with no resistance, another property of superconducting materials when they become superconducting is that they push out any magnetic field. And we're going to demonstrate that. I'm going to put a little magnet, you can see a little cube there, that's a little magnet on top of the ceramic disc, and I'm going to start cooling it down with liquid nitrogen. I'm just going to add some liquid nitrogen to the dish. And we'll just watch. You may notice some of the liquid nitrogen skating around, little droplets skating around on the surface of the table if you watch closely. That's called the Leidenfrost effect. The table is much hotter than the boiling point of the nitrogen, so the nitrogen evaporates from the bottom of the droplets and they actually ride around on a cushion of evaporating nitrogen. Now, as we keep cooling down the disk, it will take a while for it to go through the transition into becoming superconducting. But when it does, the disk will push out the magnetic field around the little magnet and lift it up. And you can see that's starting to happen now. The magnet is starting to rise above the disk. There's a little bit of a gap there. And you can actually see the magnet floating there on it's just floating on top of the magnetic field. It's being repelled by the disk because the superconducting disk is pushing the field lines from the magnet out. You can see it's up a millimeter or two, and this is called magnetic levitation. So the disk on the bottom is superconducting, the magnet on top is being the magnetic field is being pushed out of the superconducting disk, and you can see that it is just floating above the superconductor. And people have thought about using this kind of idea for levitating trains and monorails so that they can travel without friction, and that's something that may happen in the future. Okay, and you can see the disk floating there now a couple of millimeters above the magnet floating a couple of millimeters above the superconducting disk.